Hi, I'm Ms. Matsuoka, and I'm going to teach you about how to solve quadratic word problems. I have two types. One is the type I have written here, and I have one other type that I'll show you later. The first one is you have this ball, it's being thrown in the air, you have a distance to the ground, it's being modeled by a certain equation, and the first question is how high up is the ball after 2 seconds? For any word problem, you really need to figure out what x and y really stand for. So in this case, x is going to stand for the time in seconds. We also have y, and y is the distance to the ground. But another way to say distance from the ground is the height. And that's being measured in feet. So we have to think about what do we do with the 2 seconds. Well, it's seconds, so that means it's time, right? So which means it's x. So we're just going to plug it in for x. We're using this equation right here, and we're plugging 2 in for x. We have y equals negative 2 squared plus 6 times 2 plus 7. So I'm just going to simplify this. So I get y equals negative, that's going to be 4 plus 12 plus 7. In total, this is going to give me 15, right? Because negative 4 plus 12 gives me 8, plus another 7 is 15. And remember, height is in feet, so this is going to be 15 feet. Alright, so now we have our first one done. Now we look at our next problem. The next problem says, when does the ball land? So when is a time question? So we're trying to answer for x. We're trying to find x here. And the big hint here is, when does the ball land? So when the ball lands, it is how high off the ground, right? What is the height? Because we're trying to think about, like, if we're trying to find x, that means we probably know something about y. So if the ball's on the ground, it is 0 feet off the ground, right? It's on the ground. So this is going to be 0 is y. So 0 equals, and it's this equation, the same equation right here that we're using. So negative x squared plus 6x plus 7. And this is almost completely set up for solving by factoring. The only thing that we haven't really done yet is, well, we need to get this x squared by itself. So I want to get the x squared by itself. We're going to divide by negative 1 to do that. If this was a 2 in front, I would divide everything by 2. So I'm dividing every single part by negative 1 here. I'm going to simplify it. So that's x squared minus 6x minus 7. And now I solve by factoring. So on the top I have that negative 7. On the bottom I have the negative 6. So on the sides I'm going to have negative 7 and positive 1. So I'm going to write it as factoring, x minus 7 times x plus 1. So here, remember I set each part equal to 0. This is just solving by factoring like in my other video. And I'm just getting x by itself. So I'm going to add 7 to both sides here, and subtract 1 from both sides here. Whoops. Let me make that a little bit more clear. So in total here I get x equals 7. And on this one I get x equals negative 1. Now I have to think about which one answers the question the best. The question again was, when does the ball land? And we're looking for a specific number of seconds. So we have 7 seconds, and we also have negative 1 seconds. Negative 1 seconds means we're going back in time by 1 second. That doesn't make sense for the problem. So that's not going to be our answer. Our answer is 7 seconds. Okay, now on to our last question. What's the highest altitude of the ball? So if we're talking about the highest, or the lowest, or the most, or the least, that all comes down to either maximum or minimum, which means we need to find the vertex. So I've talked about how to find the vertex before. Remember, to do that we need to find the axis of symmetry first, which is that x equals negative b over 2a formula. And then remember, we plug this back into the equation to find our y value for the vertex. So here we go. We have x equals negative b over 2a, so I need a, b, and c. A in this problem is negative 1, b is 6, and c is 7. So now I plug in. x equals negative 6 over 2 times negative 1. So this gives me negative 6 over negative 2, which is positive 3. Now, the reason we need to plug this back into the equation is because we got x. X is our time in seconds, but we're looking for the highest altitude, which is the height. So because we're looking for the height, we need to find y, which means I plug it back into this equation right here. So it's y equals negative, and then 3 squared plus 6 times 3 plus 7. So I get y equals negative, that's going to be 9 plus 18 plus 7. And in total, this gives me, let's see, those two together is going to be 9 plus 7 is going to give me 16. This is being measured in feet. Okay, so now we have completed this example. Like I said earlier, I will show you one other example of a different type of problem, and then I'll give you your bonus questions. Okay, so this is our second type of quadratic word problem. We have a rectangle. Its area is 66 centimeters squared, and you have the side length sorta, but you don't know exactly which numbers they are. So that's the main question. We want to know what the side lengths are. So to do that, you have to think about what the area is, or what area is in general. So area is length times width in a rectangle. So you're really multiplying the length times the width to get the area. So I'm going to write that down. It's just length times width. So the length times the width is equal to the area. And now I'm just going to solve this out. So first I need to multiply it out. So to multiply it out, you should look up my multiplying polynomials video. If you're not sure, I'm just going to FOIL this. So it's x squared minus 3x plus 2x minus 6 equals 66. I'm going to combine like terms here. So it's going to be x squared minus x minus 6 equals 66. From here, I'm going to solve by factoring. So to solve by factoring, I need to get it to equal 0. So in order to get it to equal 0, I need to subtract 66 from both sides. So this is going to be x squared minus x minus 72 equals 0. Now if you're unfamiliar with how to solve by factoring, look up my solve by factoring video. Okay? So I'm going to go ahead and factor this now. On the top I get negative 72. On the bottom I get negative 1, so on the sides I get negative 9 and positive 8. So here I'm going to have x minus 9 times x plus 8, and it's still equal to 0 here. I set each part equal to 0. And here I need to get x by itself, so I'm adding 9 to both sides on this one. So in total I get x equals 9, and on this one I'm subtracting 8 from both sides. So in total here I get x equals negative 8. Now it's always important to know what question you're answering. Remember, we're answering this question right here. What are the side lengths? We haven't really answered that question yet. So my side lengths are x plus 2 and x minus 3, and I need to do something with them. Here I have values for x, so let's just go ahead and plug them in. So I have that x plus 2, so that's going to be 9 plus 2 here. And I have the x minus 3, which is 9 minus 3 here. So 9 plus 2 is 11, and 9 minus 3 is 6. We're going to do the same thing with the negative 8. So we do x plus 2, so that's negative 8 plus 2, and x minus 3, so negative 8 minus 3. This gives me negative 6 here, this gives me negative 11. Now I have to think about which one, or ones, maybe they're both right, so we need to think about which one's correct. So we're looking to see, like, again, the side lengths, we have that this area is in centimeters squared, so that means both of these side lengths are going to be in centimeters. So if I say like 11 centimeters and 6 centimeters, that makes sense, okay? Because you can have those lengths. However, when I have like negative 6 centimeters and negative 11 centimeters, that doesn't make sense because you can't have a negative distance. So these are not going to be your answers. Alright, now I'm going to go ahead and give you your bonus questions. Here are your 2 bonus questions. The first one is you have a pizza that's thrown from a tall building. Its position is modeled by the equation y equals negative x squared plus 4x plus 60. And we have the questions, how high up is the pizza after 3 seconds? When does the pizza land? And what's the highest altitude of the pizza? The second question is the rectangle area problem, and it's what are the side lengths? You have x and x plus 5 for the side lengths, and 66 meters squared for the actual area. Feel free to look back through the video, pause it when you need to, looking at the steps, or just replay parts over again if you need to. Good luck!